Chapter 14. Sources of Energy. Sources of Energy. Energy. In our day-to-day life, we perform various activities. In order to perform these activities, we need energy. Scientifically, energy is defined as the capacity to do work. Energy exists in different forms. The green plants use solar energy to prepare food. We need heat energy to cook our food. We use electrical energy to light our houses and to run appliances like fans, refrigerator, washing machines, etc. In our surroundings, we observe that energy changes from one form into another. Can you think of any example? Well, we know that during photosynthesis, light energy from the sun is converted into chemical energy contained in the food prepared by the green plants. In an electric lamp, electrical energy is converted into light energy. Electrical energy is converted into sound energy when we use a microphone. Thus, we can say that energy can neither be created nor can be destroyed, but it gets converted from one form to another. This is known as transformation of energy. If energy cannot be destroyed, then why do we face energy crisis? To understand this, consider an example. What kind of change happens when a piece of paper is burnt? The chemical energy of the paper gets converted to heat and light energy. Now, can you do some process to get the same paper back again? Let us consider another example. Take 100 milliliters hot water in a beaker. Place the beaker in open space. What do you observe? You will observe that the temperature of the water falls down. This happens because of the heat exchange within the water and the surroundings. Is there any method or process by which the heat lost by the water can be gained back? Well, in both the examples, the energy gets converted from the usable form to the less usable form. Therefore, we can say that certain forms of energy are more useful than the other. For example, electric energy is the most useful energy as it is easily convertible to any other forms of energy. Hence, any source of energy used to perform work is consumed and cannot be used again. We require energy to do work. The energy required to do work is supplied by a source of energy. Depending on the type of work, different types of energy sources are used. The selection of the source is very important. How do we find out that what can be considered to be a good source of energy? Let us study the qualities or the characteristics of a good source of energy. It should give large amount of work per unit mass or per unit volume. It should be cheap and easily available. It should be safe to handle and use. It should be easy to store and transport. It should not cause any environmental pollution. Conventional sources of energy. Energy sources that has been used from ancient times are known as conventional energy. Conventional or traditional energy sources consist primarily of fossil fuels, for example, coal, natural gas, and petroleum. Let us study about them in detail. Fossil fuels. Natural resources such as coal, mineral oil, and natural gas are called fossil fuels. They are called fossil fuels because they were formed from the organic remains of dead plants and animals that lived about 300 million years ago. Fossil fuels are found in deposits beneath the earth. Now let us understand how these fossil fuels were formed. About 300 million years ago, the organic remains of plants and animals mixed with silt and mud to form layers. With the passage of time, mineral sedimentation formed on top of the organisms, effectively entombing them in rocks. Over millions of years, absence of air, high temperature, and tremendous pressure of the layers of the earth transformed the dead organisms into fuels. As these fuels were formed over a long period of time, they cannot be replaced as fast as they are being consumed. The stores of fossil fuels are limited, and that is why they are also called exhaustible resources. But today, we are consuming these resources at such an alarming rate that sooner or later their stores would vanish. Thus, there is a need to spread awareness to all the people about the fact that we have to make a prudent use of these resources and use renewable sources of energy more extensively for our needs. It is interesting to know that fossil fuels exist in all the three forms, that is, solid, liquid, and gas. Coal, mineral oil, and natural gas are examples of these three forms respectively. Let us understand and learn about these three fossil fuels. Coal. Coal is a solid fossil fuel. It is believed that coal was formed from plants such as ferns, moss, and trees, which lived near shorelines and in swamps and bogs millions of years ago. It is found in coal mines deep under the surface of the earth. It is one of the cheapest fossil fuel that is widely utilized for energy production. Coal mainly contains carbon. When heated in air, coal burns and produces heat energy and carbon dioxide gas. Coal was initially used in steam engines and was a commonly used fuel for cooking. Nowadays, coal is used in power plants to generate electricity and in steel plants to make steel from iron. It is also used in the production of useful products like coke, coal gas, and coal tar. Petroleum. Petra means rocks, and oleum means oil. Thus, petroleum means mineral oil obtained from rocks. Petroleum is another main type of fossil fuel which is found in the liquid form under the crust of Earth, trapped in rocks. It is also called as crude oil. Petroleum is a dark, viscous, oily liquid with an unpleasant odor. Petroleum is a mixture of many hydrocarbon compounds. It is obtained from oil wells deep in the bowels of the earth. In India, oil is found in Assam, Gujarat, Mumbai High, and in the river basins of Godavari and Krishna. Petroleum cannot be used directly as fuel. It has to be purified and separated into component forms before it can be used for specific purposes. The process of separating the various constituents of petroleum is known as refining. It is carried out in a petroleum refinery. The fractional distillation of petroleum gives petroleum gas, petrol, diesel, kerosene, fuel oil, paraffin wax, and lubricating oil as fractions. Petrol is used as a fuel for vehicles. Kerosene is used as a household fuel for stoves and lamps. It is also used for jet aircraft. Diesel is used as a fuel for heavy motor vehicles and electric generators. Fuel oil is used in big furnaces in factories. Natural gas. Natural gas is a gaseous fossil fuel and is a mixture of gaseous hydrocarbons. Natural gas was formed mainly from the remains of plankton or a type of small water organisms. It consists mostly of methane, CH4, and other gases like ethane, C2H6, propane, C3H8, and butane, C4H10. Natural gas is often found on top of deposits of petroleum due to its lower density and is extracted in the same process. However, deposits containing only natural gas do exist. Natural gas is comparatively more desirable and convenient to use because it lights up quickly and burns cleaner than coal and petroleum without leaving behind any solid residue. Natural gas is a very important fossil fuel because it is easy to transport through pipes. The great advantage of natural gas is that its burning can be easily controlled and it can be used directly for burning in homes and factories where it can be supplied through pipes. Why is it that fossil fuels are in more demand than other resources? This is because the energy obtained from these resources is much higher than the energy obtained from fuels like firewood. Do you know that 1 kg of wood gives about 1,700 kilojoules of energy, which is much less than the energy obtained from coal? Charcoal, which is obtained by burning wood, is also a common fuel in the rural areas. Charcoal is preferred to firewood because it is a more efficient fuel than wood and burns smokeless. But it is a matter of concern that forests are being cut down to meet the increasing demand of wood, which is a cheaper fuel. We all know that destruction of forests affects the environment drastically, leading to other critical problems. Therefore, we should use better domestic fuels that can be obtained from biomass, for instance, biogas. Nowadays, we find biogas plants in many areas. Use of the fossil fuels is one of the major reasons for environmental pollution. While combustion, they produce poisonous gases. This happens because of the incomplete combustion of the fossil fuels. The pollution caused by fossil fuel can be minimized by using the latest efficient technologies. Therefore, we should use better domestic fuels that can be obtained from biomass, for instance, biogas. Nowadays, we find biogas plants in many areas. Besides being used directly for various purposes like stoves at home and in vehicles, Fossil fuels are the major fuels that are used for generating electricity in power plants. Let us study how various sources of energy are harnessed to generate electricity in different power plants. Thermal power plant. In thermal power plants, the heat required to make up the steam to run the turbine is obtained by burning fuels. In thermal power plants, the chemical energy of fossil fuel gets converted into heat energy. This heat energy is used to increase the kinetic energy of the water molecules, which results in the formation of steam. The jet of high-energy steam is projected on the turbine at high pressure. This causes the turbine to rotate. The rotation of the turbines drives the generator connected through a shaft. The generator converts mechanical energy which is provided by the turbine into electrical energy. The spent steam that comes out of the turbine cools and condenses to form water. This water is again used to form steam. The process repeats again and again. This way we get electricity from thermal power plant. It is easier or cheaper to transport electricity over long distances as compared to fossil fuels. This is the reason that the power plants are constructed near coal or oil fields. In India, major part of the electricity is produced by burning fossil fuels. Hydropower plant.
Energy from flowing water. Water in seas and oceans have energy. What about water flowing through rivers? Do they possess any energy? Yes. Flowing water is also an important source of energy. Due to motion of water, it has kinetic energy. Therefore, the energy of flowing water can be used to do work. Now, let us see how the energy of flowing water is converted into electrical energy. Have you heard of hydroelectric power stations? It is in this place the energy of flowing water is converted into electrical energy. Dams are constructed across rivers to store water by obstructing the flow of water. The turbines are kept at the bottom of the dam. The water from the top of the dam is allowed to fall at high speeds over the turbine blades at the bottom of the dam. When water falls on the turbines, potential energy of the water is converted into kinetic energy. This kinetic energy of the flowing water makes the turbine rotate with great speed. Moving turbines rotate the armature of the electric generator to produce electricity. Energy obtained from flowing water is called as hydroelectric energy. The place where hydroelectricity is generated is called hydroelectric power station or hydroelectric power plant. There are many problems associated with the construction of hydroelectric power plants. Can you think of some problems? We know that dams cannot be constructed at all places. When dams are constructed, large land area gets submerged. It results in dislocation of population, loss of fertile area, and useful plants. Hence, before constructing high-rise dams to generate electricity, special efforts should be taken regarding its impact on the environmental and social life. Then, what may be the solution for this problem? Instead of constructing big plants, mini plants can be constructed on the rivers, in the hilly regions. What are the advantages of hydroelectricity? The advantages of hydroelectricity are: 1. They are eco-friendly. 2. They cause no pollution. And 3. Construction of dams helps in controlling floods and supplies water for irrigation throughout the year. Can you name some hydropower stations in India? In India, hydropower stations are located at Bhakhra Nangal, Chamba, Chibru, Sundarnagar, etc.
Improvements in the technology for using conventional sources of energy. We know that wood has been used as a fuel for a longer time at a very fast pace. This has resulted in limited reserves of these fuels on the earth. If we can ensure that enough trees are planted, a continuous supply of firewood can be assured. There have been some improvements in the technology over a period of time in order to use the conventional sources of energy. Let us learn some of them in detail.
Energy from biomass. What is biomass? The material contained in the bodies of dead plants and animals is called biomass. It includes the waste material of living objects like cattle dung, dead parts of living objects like plants, trees, and animals, and agricultural wastes. The energy from biomass can be used directly as well as indirectly. The direct method of using biomass is to burn it. Even nowadays, if you go to the villages, you can see people burning wood and cow dung cakes in traditional chullas for cooking food and heating water. But the efficiency of these traditional chullas is very low. It is less than 15%. Therefore, the use of traditional chullas results in wastage of fuels. Moreover, it also produces smoke which leads to serious health hazards. So, efforts have been made to improve the design of chullas so that more heat is transferred to the cooking pots. Technology has led to the development of smokeless chullas which transfer more heat as compared to the traditional chullas. Biomass can be used indirectly by converting it into convenient fuel in solid, liquid, or gaseous form. There are two conversion processes: 1. Biological conversion, and 2. Thermochemical conversion. Biological conversion includes processes like fermentation. For thermochemical conversion, a gasifier is needed, of which the end product is a mixture of producer gas N2, CO, H2, CO2, and CH4. Biogas. Biogas is a gaseous fuel obtained from biomass. It is a mixture of gases such as methane, carbon dioxide, hydrogen, and hydrogen sulfide. It is produced by microbial decomposition of organic matter in the absence of oxygen. It is a clean combustion fuel that can be used for cooking, water heating, and lighting also. It is used to produce mechanical power in agriculture machinery, water pumping, and to generate electricity. In India, as the cattle production is large, the production of biogas is more significant. Biogas is produced in biogas plants. Let us now understand the construction and working of a biogas plant and learn how biogas is produced in a biogas plant. A biogas plant consists of two parts, a digester and a dome. Dome may be fixed or floating. There's a gas outlet at the top of dome for the supply of biogas. Digester is a well containing animal waste in the form of slurry. Slurry is a mixture of animal waste and water mixed in equal proportions. On one side of the digestion tank, there is a sloping inlet chamber. On the other side of the digester, there is an outlet chamber. Mixing tank is connected with sloping inlet chamber. The inlet chamber is for introducing fresh dung slurry into the main digestion tank, whereas the outlet chamber is for taking out spent slurry, called sludge, after extraction of biogas. Now, let us observe the working of a biogas plant. Animal waste and water is mixed in equal proportion to make the slurry in the mixing tank. The slurry is fed into the digestion tank through the inlet chamber. The tank is partially filled so that there is enough space for the collection of biogas that would be formed. Inside the digester, the action of microorganisms breaks down or decomposes the complex compound of biomass in the slurry. The slurry undergoes fermentation by anaerobic bacteria in the presence of water. The process takes place for few days. As a result of the fermentation, biogas is formed, which is collected at the top of the dome. As more and more biogas is formed, it exerts pressure on the slurry in the digester and forces it to go into the overflow tank through the outlet chamber. The sludge coming out of the digester retains nitrogen, phosphorus, and potassium originally present in the animal waste and hence is an excellent fertilizer. Once the biogas plant starts functioning, more and more slurry may be fed into the digester to get a continuous supply of biogas. The biogas is taken out through a pipe and is supplied to the customers. A biogas contains around 80% of methane. It is an excellent fuel and burns without smoke. It is used as a fuel in industries and at home. Biofuels. Biofuels are renewable energy sources of fuel obtained from biomass. Biofuels include ethanol, biodiesel, and biogas. Biodiesel. Biodiesel is also a renewable energy source obtained from biomass. It is extracted from seeds of soybean and corn. It is used as a substitute fuel in the place of diesel in diesel engine. It is non-poisonous and it is biodegradable. In India, oil is obtained from seeds of jataropa, karanj, and nag champa, and it is used in the production of biodiesel. It is considered as a clean fuel since it has almost no sulfur, no aromatics,
and has usually
10% inbuilt oxygen, which helps it to burn completely. If waste land in India is brought under jataropa cultivation, it will give 1.5 tons of seed per hectare. It is estimated that equivalent amount of biodiesel will be produced, which will fulfill 1/10 requirement of diesel in our country. wind energy. Due to alternative heating and cooling of the earth, there is a difference in the atmospheric pressure. This difference in the atmospheric pressure causes the air to move from high pressure area to low pressure area. We call this moving air as wind. The wind has kinetic energy, which is called as wind energy. Have you ever used wind energy for any purpose? You use wind energy while flying a kite. You might have played with a whirligig, a small toy made of paper which spins around when taken out in the air. It uses wind energy to spin. Where else is this wind energy being used? Farmers use wind energy for winnowing, that is, to remove husk from the grain. Sailors use wind energy to sail boats. Wind energy also causes damages. When they come in the form of hurricanes, tornadoes, cyclones, they cause destruction of life and property. Have you seen a windmill? A windmill is the equipment which converts wind energy into electrical energy. It has a structure similar to a large electric fan. It is erected at some height on a rigid support. The blades, the shape of the blades, and the height of the windmill from the ground are decided on the basis of the wind velocity. The blades are designed in such a way that they create a pressure difference on the blades. This pressure difference makes the blade to rotate. This rotatory motion of windmill is used to rotate the armature of the electric generator. It has been observed that the electricity generated by a single windmill is quite small. Therefore, a number of windmills are erected over a large area. This area is called wind energy farm. The electricity generated by each windmill is coupled to generate electricity on a commercial scale. Can you tell some advantages of wind energy? Wind energy does not cause any pollution. The source of wind energy, that is air, is inexhaustible.
Wind energy is an environmental-friendly source of energy. It requires no recurring expenses for the production of electricity. But there are some limitations in the use of wind energy. Windmills can be economical in those areas where wind blows for the greater or major part of the year. Also, the wind speed should be higher than 15 km per hour to maintain the required speed of the turbine. The land requirement and the initial cost of establishment of a windmill is quite high. Windmills require high level of maintenance. Denmark is called as the country of winds. It is because they produce more than 25% of their electricity needs through a vast network of windmills. In terms of total energy output through windmills, Germany is the leading country of the world. Our country is ranked 5th in harnessing wind energy for the production of electricity. Alternative or non-conventional sources of energy. The sources of energy which are not based on burning of fossil fuel or nuclear fuel are known as alternative or non-conventional sources of energy. The demand for energy has increased with the technological advancement. As a result, we need to look for more and more sources of energy. Non-conventional sources of energy can be used as one of the options. These are renewable in nature. Renewable energy sources are the sources that have inherent capability to reappear or replenish themselves by quick cycling, reproduction, and replacement within a reasonable time. Wind energy, tidal energy, geothermal energy, energy from flowing water, energy from sun, and energy from biomass are examples of non-conventional sources of energy. Let us discuss some of the renewable energy sources in details. Solar energy.
Energy from sun. So far, we have discussed different sources of energy such as wind energy, hydro energy. Where do they get their energy from? You all know that energy can neither be created nor destroyed. So, some energy must have been converted into the kinetic energy of wind. What is that energy? It is the sun's energy. Sun is a big storehouse of energy. The sun's energy is produced by the nuclear reactions going on inside it all the time. All our energy comes from or has come from the sun. The sun's energy gets transformed into many other forms of energy which are useful to us. Let us discuss some information about the sun. Sun is a large sphere of hot gases. It is at a distance of about 1.5 into 10 to the power 8 kilometers from the earth. The diameter of the sun is 1.4 into 10 to the power 6 kilometers. The mass of the sun is 2 into 10 to the power 30 kilograms. Because of high temperature prevailing inside the sun, various fusion reactions take place inside the sun. In these reactions, hydrogen nuclei is converted into helium nuclei. Such reactions are called nuclear fusion reactions, as the reactions take place inside the nuclei of the atoms. Heat is created due to these fusion reactions. In the process of nuclear fusion reaction, 4 hydrogen nuclei combine to form one helium nucleus. The mass of helium nucleus is slightly less than the total mass of the hydrogen nuclei. This mass difference is converted into energy. As large number of helium nuclei is formed per second, extremely large quantity of energy is continuously liberated by the sun in the form of heat and light. This energy is in the form of electromagnetic radiation. It is called the solar energy. It is radiated in all directions in space. The Earth and other planets receive only a small fraction of this energy. The power available on Earth from the sun
is around
1.8 into 10 to the power 11 megawatts. This power is many times more than the present power consumption rate and future energy needs of the world. Thus, solar energy is the only source that satisfies the present and future needs of the world. This makes solar energy one of the most promising energy sources. The main advantages of solar energy are: solar energy is a very large and inexhaustible source of energy, and it is a clean source of energy, and its use does not affect the environment. But there are limitations for the use of solar energy. The solar energy is a dilute source of energy. In order to collect sufficient amount of energy, large collecting surfaces are required. Special devices are to be designed to concentrate the solar energy. This increases the cost of solar devices. The availability of solar energy varies from time to time. It is not available in sufficient amounts in all the time. The variation in the availability occurs due to day-night cycle, seasonal changes due to motion of Earth around the Sun, and local weather conditions such as cloud cover, wind, etc. Because of these problems, it becomes necessary to store available solar energy when the sun is shining. This stored energy can be used during the period when solar energy is not directly available. But the storage equipments increase the cost of the system to be used. Thus, the real challenge in utilizing solar energy as an alternate source of energy is to make it cheaper. New technology has been developed to harness solar energy into efficient and conventional way. Can you mention some devices which work with solar energy? Solar cooker, solar water heater, solar dryer, solar cells are some devices which work with solar energy. These devices are called solar energy devices. These are the devices which work using solar energy. Where do you use solar energy directly? Use of direct solar energy is in drying of clothes, drying of grains, etc. Plants use solar energy to prepare their food by the process of photosynthesis. Now, let us understand how these solar devices are designed to make use of solar energy.
Solar cooker. Have you ever seen a solar cooker? It is a device used to cook food items like rice, dal, vegetables that require slow heating with the help of solar energy. Before we understand the construction of a solar cooker, let us understand the working principle of a solar cooker. Let us perform an activity. Take 2 tin cans. Paint one can black and the other can white in color. Fill both the cans with water. Place the cans in direct sunlight for an hour. After an hour, measure the temperature of water in both the cans. You will observe that the water in black can is warmer than the water in the white can. It is because, under identical conditions, the black surface absorbs more heat energy as compared to the white surface. Now, keep the same cans in shade for an hour. Touch the water in the cans. What do you observe? You will observe that the water in the black can cools faster than the water in the white can. What is the mystery behind this? Well, this is because the blackened surface is an excellent absorber as well as an excellent emitter of heat. Many solar devices use this principle for their working.
Let us understand the construction of a solar cooker. A solar cooker consists of a box made from non-conducting material like plastic or fiberglass. The inner surface of the box is painted black. The use of black surface is to absorb more heat. It absorbs 98% of the incident heat radiation. The walls of the box are made thick with a lining of non-conducting material to prevent loss of heat. It has a glass cover on the top. The glass cover facilitates the retention of heat inside. A plane mirror is hinged on the top of the box. the food to be cooked is kept in shallow vessels or metal cooking pots. The outer surface of the cooking vessel is also painted black. Then it is kept inside the box. The mirror is adjusted in such a way that maximum radiation is reflected into the enclosure. These rays pass through the transparent glass sheet and are absorbed by the black box and the containers. The temperature inside the solar cooker is about 100 degrees Celsius to 140 degrees Celsius when they are kept in sun for 2 hours. This heat cooks the food in the containers. Let us learn about some of the advantages and disadvantages of a solar cooker. The advantages of a solar cooker are: the use of solar cooker for cooking saves fuel. It causes no pollution. And since food is cooked at low temperature, the food retains its nutrients. The disadvantages of a solar cooker are: the solar energy is not available in sufficient amounts all the time. It cannot be used during night time, and it cannot be used for frying or baking, which requires higher temperature. The type of solar cooker we discussed is a box-type solar cooker. Solar cookers are available in many designs of different shapes and sizes. Solar water heater. Now, we may proceed to understand the construction and working of a solar water heater. A solar water heater has two main components. 1. A flat plate collector, and 2. The insulated storage tank. Construction and working of a solar heater. In the flat plate collector, copper pipes with its outer surface painted black are fixed in the form of coil and is kept in a box covered with glass. Bending of pipe helps to increase the surface area for heating. A reservoir or storage tank is kept at a higher level. It is used to store cold water, which is connected to a small tank kept slightly above the flat collector. One end of copper pipe is connected to the bottom of small tank of water, while the other end is joined to its middle. The water in the tank continuously circulates through copper pipe due to small pressure difference between two ends. As water slowly moves through the copper pipe, it absorbs solar radiation and gets heated. The normal water again goes into the tank, while the cooler water enters the copper pipe from the lower end. The water in the tank thus gradually heats up. Hot water is lighter, and it remains in the upper part of the tank. The hot water can be drawn through a tap. The cold water in the reservoir replaces the hot water drawn out from the storage tank. Solar dryer. As you infer from the name, it is used as a dryer. It is used to dry grapes. What do you call dried grapes? Dried grapes are called raisins. Solar cells. Solar cells. Can you identify this picture? Well, these are solar cells. Solar cells are devices which directly converts solar energy into electrical energy. These are also called as photovoltaic cells. Modern solar cells are made of silicon. Silicon is easily available in abundance and it is environmental friendly. Solar cell consists of a number of thin layers of silicon. They convert solar energy into electrical energy. A typical solar cell is a 2 centimeter square piece of silicon which produces about 0.7 watts of electricity when exposed to sunlight. Hence, large number of solar cells is combined together. Such a combination of solar cells used to produce enough electricity is called a solar panel. Let us list down some of the uses of solar cells. Solar cells are extensively used as a main source of energy for artificial satellites. They are used as source of energy for radio or wireless transmission at TV relay stations, traffic signals in the remote areas. They are widely used in calculators and toys. And they are also used to pump water for irrigation, for lighting the rural area and remote villages.
Energy from the sea.
Tidal energy. We have seen how wind energy is used to generate electricity. Similarly, energy from the tides can also be converted to electrical energy. What are tides? How are they formed? The movement of water level along shore is known as tides. Tides are generated by the gravitational attraction between Earth and Moon twice a day. Tides raise the water level by few meters. The energy possessed by rising and falling water in tides is known as tidal energy. Electricity can be generated from such tides. In order to generate electricity from tides, usually dams are constructed across narrow opening to the sea. The water moves in and out from this opening during tides. As soon as water flows through the opening, it flows over the turbines fixed inside the dam. The turbine rotates and generates electricity. There are certain limitations in using the tidal energy. They are: 1. Rise and fall of water during tide is insufficient to generate electricity on a large scale. And 2. There are few sites along the coast where dams can be constructed. It is important to note that without constructing dams, it is not possible to convert tidal energy into electrical energy.
Wave energy. Waves are caused by the strong winds blowing over the surface of the ocean. In many areas of the world, the wind blows with enough consistency and force to provide continuous waves. There is tremendous energy in the ocean waves. This energy is used for the rotation of turbine that generates electricity. A wide variety of devices have been developed to trap this energy. Wave energy varies considerably in different parts of the world due to the various geographical reasons. Therefore, wave energy cannot be harnessed effectively everywhere. It can be harnessed only in the areas where wind blows with enough force to provide continuous waves. Ocean thermal energy. The heat energy possessed by ocean is known as ocean thermal energy. Let us understand how is it used. During the daytime, sea surface gets heated due to sunlight, while the water in the deeper parts of the sea remains cool. This gives rise to the temperature difference between the surface and the deeper parts of the sea. The plant can operate only if the temperature difference between the surface and the depth of up to 2 kilometers is 20 degrees Celsius. This difference is used to obtain electrical energy in ocean thermal power plant. The greater the difference, the more is its efficiency. In an ocean thermal energy conversion plant, the warm water on sea surface is used to boil a volatile liquid ammonia. On boiling, ammonia converts into vapors. The vapors of the liquid are then used to run the turbine of the generator that produces electricity. The colder water from the deeper ocean is pumped up to cool the used-up vapors of ammonia. This condenses the vapors again to liquid. This process is repeated again and again. The temperature difference between the surface and deeper parts of sea is greatest in the tropics. It is around 20 degrees Celsius to 25 degrees Celsius. Therefore, the construction of ocean thermal energy power plant is more favorable in tropical region. The main challenge of ocean thermal energy conversion is to generate significant amount of power efficiently from small temperature differences. It is still considered as an emerging technology. Geothermal energy.
What do you mean by geothermal energy? Geo means earth, and thermal means heat. The energy obtained from interior parts of the earth is called geothermal energy. It can be used as a source of energy under certain conditions. We know that the interior region of Earth is very hot. This heat melts the rocks. The molten rocks are known as magma. Whenever there are some geological changes, the magma is pushed upwards, which gets collected at some depth below the surface of Earth. These places are called spots. These spots are sources of geothermal energy. When underground water comes into contact with spots, water gets converted into steam. The steam thus generated is trapped in rocks. This steam gets compressed under high pressure. This steam is extracted by sinking pipes through holes drilled up to spot. The steam extracted in this way can be utilized to turn turbine of electric generator. Have you heard of hot water fountains and springs in some volcanic regions? These hot water springs and fountains are called geysers. These geysers are also sources of geothermal energy. The limitation of geothermal energy is that as the spots and geysers are not available on all parts of the world, geothermal energy is used as a source of power only in the places where they are available.
Nuclear energy.
What is nuclear energy? From the name itself, you can understand that it is the energy obtained from the nucleus of atoms. The reactions in which the nucleus of an atom undergo transformation, forming new atoms and releasing tremendous amount of energy, is called nuclear reactions. The energy released from these reactions is called nuclear energy. The nuclear reaction is of two types. 1. Nuclear fission, and 2. Nuclear fusion. What do you mean by fission? Fission means breaking. So, nuclear fission reaction is the reaction in which the nucleus of a heavy atom splits into many atoms of small nuclei with the liberation of large amount of energy. What do you mean by fusion? Fusion means combining. Thus, Nuclear fusion is the process in which two or more nuclei of higher atoms combine to form a heavy nucleus with the liberation of large amount of energy. There are two ways to obtain nuclear energy, namely 1. Breeder reactor, and 2. Nuclear fusion. Breeder reactor. Uranium has three isotopes: uranium-234, uranium-235, and uranium-238. Out of these, the percentage of uranium-238 is more than 99%. Uranium-235 undergoes spontaneous fission when bombarded with a slow neutron. The breakup of uranium-235 when subjected to neutron bombardment gives fission products barium and krypton and 3 neutrons along with the release of large amount of energy. The neutrons released during the fission reaction are slowed down by a moderator and made to bombard new nucleus of uranium-235, thereby setting a controlled chain reaction. The working of a reactor in which this reaction takes place is called burner reactor. The isotopes which can undergo fission are called fissile material. Thus, uranium-235 is a fissile material. Uranium-238 is not a fissile material, but it is a fertile material. Fertile material is one which can be converted into a fissile material under certain conditions. The uranium-238 can be converted into plutonium-239 by neutron bombardment, and this plutonium-239 is a fissile material which can undergo fission reaction. Here also, during the fission reaction, neutrons are emitted along with the fission products. The neutrons emitted in this reaction serve two purposes. First, they convert fertile material uranium-238 to fissile material plutonium-239. Then, they sustain the fission of plutonium-239. Such reaction in which the fertile material gets converted into fissile material is called breeder reactions. The reactors in which such reactions take place are called breeder reactors. In India, the first breeder reactor was commissioned at Kalpakam near Chennai. It gives out 40 megawatts of thermal energy.
Matter can be converted into energy. This fact was first discovered by Albert Einstein in 1905. In nuclear fission, the difference in mass delta M between the original nucleus and the product nuclei gets converted to energy E. This mass-energy conversion is given by the relation E equals to mc square. In nuclear science, energy is measured in electron volts, symbolized as EV. 1 electron volt of energy is equivalent to 1.602 into 10 to the power minus 19 joules. The energy released in nuclear reaction is very large. Therefore, to measure the nuclear energy, bigger units such as million electron volt and trillion electron volt are used. To find 1 million electron volt, let us multiply 1.602 into 10 raised to minus 19 joules by 1 million, that is 10 to the power 6 joules. Or it is equal to 1.602 into 10 raised to the power minus 13 joules. Now, let us calculate the amount of energy that would release when a unit mass is completely converted to energy. Consider a matter having mass of 1 atomic mass unit. We know that the exact mass of atomic unit is 1.66 into 10 to the power minus 27 kilograms, and the exact value of the speed of light is 2.998 into 10 raised to the power 8 meter per second. Putting these values in Einstein's equation, we will get 1 atomic mass unit is equal to 1.492 into 10 raised to the power minus 10 joules. To convert this energy into million electron volts, divide right-hand side by 1.602 into 10 to the power minus 13 joules. This will give us the value of atomic mass unit, which is 1 atomic mass unit is equal to 931 mega electron volt, or 1 U is equal to 931 mega electron volt. Thus, 1 atomic mass unit, that is U, is equal to 931 mega electron volt of energy. Nuclear power is widely used for generation of electricity. Developed countries like France, Finland, Belgium, Germany, Hungary, Japan, Sweden, Spain, and Switzerland generate more than 30% of their total electric power by using nuclear energy. The greatest concern with nuclear power is nuclear waste storage and disposal. The nuclear waste are radioactive and keep emitting harmful radiations for thousands of years. This results in contamination of environment. To avoid this contamination, we need to dispose the nuclear waste properly. Further, there are chances of accidental leakage of nuclear radiations. One such worst nuclear power plant disaster that took place in the history was the Chernobyl disaster in USSR. The most common and long-term effect of radiations is mutation leading to the abnormalities in offsprings. Leukemia and breast cancer are the two common types of cancers linked to exposure to radiations.
Nuclear fusion. In nuclear fusion reaction, 2 or more atoms of smaller nuclei combine to form a nucleus of higher atomic number along with the release of large amount of energy. Fusion reactions are done in a controlled manner in fusion reactors, and the energy released is used for constructive purposes. In nuclear fusion reaction, isotopes of hydrogen combine to form helium nucleus along with the release of huge amounts of energy. Deuteron, which is an isotope of hydrogen, is also used as a fusion material. It occurs naturally in seawater, and it is estimated that fusion of all deuterons in just 1 cubic meter of seawater would yield energy of 12 into 10 to the power 9 kilojoules. Thus, fusion of deuteron is also another ultimate source of energy.
Environment consequences. The overdependence on these fossil fuels has paved way to many other serious problems like global warming and atmospheric pollution. During combustion of the conventional fuels, many gases like carbon dioxide, sulfur dioxide, and oxides of nitrogen are released into the atmosphere. The concentration of carbon dioxide gas in the atmosphere is constantly increasing, and this has led to greenhouse effect and global warming. Global warming means a rise in the atmospheric temperature across the globe, which is quite alarming as it results in the melting of the snow on the mountain peaks exceeding the normal pace. Presence of higher concentration of sulfur dioxide has given rise to dangers like acid rain. Use of compounds has led to ozone depletion, thus creating holes in the ozone layer, which is a protective layer in our atmosphere. This leads to the free passage of harmful ultraviolet rays from the sun to the earth, which is responsible for many health hazards. The need for firewood and charcoal has resulted in the unrestricted felling of trees in the forests. Further, the degradation of forests poses a threat to the biological diversity.
The energy source that we choose to use depends on various factors like cost, the ease with which it is available, the efficiency of the technology available, and the environmental damage that will be caused by using that source. There is nothing like ideal source of energy. Every source of energy, more or less, pollutes the environment. Devices like solar cell may be considered as pollution-free, but its components are made of toxic materials which, when disposed, causes environmental problems. Exploiting any energy source disturbs the environmental balance, so they must be harnessed judicially. Researchers are working to provide us a low-cost, pollution-free, and efficient energy source. How long will an energy source last us? We know that conventional sources of energy are exhaustible sources of energy. They are also known as non-renewable sources of energy. We have been using these energy resources at a very alarming rate. The amount of coal, petroleum, and natural gas left on Earth is limited. It has been estimated that the world's known coal reserves are expected to last for another just 200 years. Petroleum and natural gas reserves are expected to last for around 50 years. So this is the high time to promote the use of alternative sources of energy and conserve fossil fuels. Some steps that can be taken in this regard are: all electrical appliances should be switched off when they are not required. Energy-efficient electrical appliances should be used. For example, instead of conventional electric bulb, fluorescent lamp and tube lights can be used. Good quality fuel burners should be used to obtain maximum heat. Pressure cookers should be used to save fuel. Whenever possible, a solar cooker should be used to cook food, and solar water heater should be used to get hot water. Biogas can be used in place of LPG in rural areas. Bicycle can be used for short distance traveling. This saves fuel like petrol.